All right, so we are starting chapter 4 by looking at what the graph of a quadratic function looks like. We've mentioned this already in earlier chapters. It's called a parabola, and I know you guys have seen it before. In earlier chapters, we had lines. Lines are super easy. You need to know how to plot 2 points. You connect the dots. It's a straight line. Doesn't get much easier than that. Parabolas, you've got a couple different features that you need to be able to plot and plot accurately. And so this first little piece right here, I'm going to walk you guys through kind of some of the vocabulary and the different features that parabolas are going to have. So when we are graphing quadratic functions, so first of all, this is a quadratic function here. F of x, remember that's our function notation. And this is the standard form that you guys are going to see whenever we deal with quadratics. Okay, so ax squared plus bx plus c. So first of all, just in terms of some vocabulary, like I said, you have 3 different terms that you can see here. So this is the quadratic term is right here. That's the x squared term. The linear term is right here. That's just the plain old x term. So this is what we had. Without this, this just looks like a linear function, just like a straight line. And then the constant term is this constant that's not attached to a variable at all, that's c. So whenever I refer to one of these 3 terms, make sure you know which piece of the quadratic equation we're talking about. So graphing it, let me show you just what a generic parabola looks like. So I'm just going to graph parabola, something like that. Okay, so now keep in mind it could be shifted any which way. It might be flipped upside down, stretched out, but this is just kind of a generic piece of what a graph looks like. So 2 super important features that I want you guys to know when we're talking about a parabola. First of all is this point right here. This point is kind of like your turnaround point. If the graph is going down, that's when it turns around and starts going up. Or if it's upside down, that's when it's going up, turns around, and starts going down. And that point is called the vertex. Okay, so this one specific point right here, we call that the vertex. We're going to be using the vertex a lot. Every single time we plot a parabola, we need to know where that vertex is. And then next, see how this is a symmetric shape? This is a mirror image of this shape over here. And so I know you guys talked about lines of symmetry in geometry. So that's what this line is right here. If it was graphed perfectly, and mine is not, this would be a perfect mirror image of this over this line right here. So that dotted line that runs down the middle, we call that the axis of symmetry. Okay, so let me give you some formulas to find these things. So the axis of symmetry, in order to find that, we have a formula, and it is x equals negative b over 2a. Okay, so x equals, remember, always just ends up being a vertical line. And the vertical line, we get b and a right here. So b is attached to the linear term, a is attached to the quadratic term. We plug it into this formula, and that tells us exactly where the axis of symmetry is. So any parabola, you should be able to plug these values into this equation, and you'll be able to find this dotted line that we have right here. And x equals, remember, makes it a vertical line. And then for our vertex, your vertex is supposed to be an ordered pair. Okay, so your vertex, you get the x value from this, because the vertex is always going to be on the axis of symmetry. So you plug in whatever you get for negative b over 2a to get y. Okay, so you plug that in to get y. So the y value you're going to have to find, and remember the vertex should end up being an ordered pair. Okay, so the axis of symmetry, remember, is a vertical line. And then the vertex should be an ordered pair. So their x values are the same, but the vertex, since it's an ordered pair, it should also have a y value. All right, and then the last little feature you want to find is this point right here. That point's the Y-intercept. Y-intercept is super easy to find. Remember, just like we did with lines, if we were trying to find a y-intercept, we plugged in 0 for x, so it's just as easy here. So our y-intercepts, you plug in 0 for x. So you'd have f of x equals, so it'd be a times 0 squared plus b times 0 plus c, so it always just ends up being c. So the y-intercept is going to be an ordered pair, and it's the point 0, comma c. Okay, so it's super easy. You can just look at it. It's just whatever the constant is, because if you plug in 0 here and 0 here, the only thing left would be the c. All right, so 3 very important points. And so I'm going to walk you guys through exactly how we would use these features in order to plot a parabola. Okay, so step 1, you're going to find the axis of symmetry. And the vertex. Okay, so you can kind of do that all at once. You'd use this formula to find the axis of symmetry. So the first thing you should be plotting is this dotted line right here. And then you know the vertex is going to be on the dotted line, so you can plug this in here to get an ordered pair. Then you'd plot the vertex. Okay, so far, all you'd have is a dotted line and then a single point on that dotted line. Then find the y-intercept. So in most cases, you'll have this additional point so far. And here's an important part. Remember, we talked about how this is a line of symmetry, so anything that happens over here can be reflected over here. So after you find the y-intercept, what you're going to do is you're going to mirror that y-intercept over on the other side. And that gives you your third point. And as soon as you have 3 points, you'll be able to connect the dots and form that shape. So you're going to find the y-intercept and its reflection over that axis of symmetry. And then finally, you're going to connect the dots, make it a parabola. So connect these 3 points with a smooth curve. Make sure it actually is smooth and rounded. You don't want to make it pointed like an absolute value graph. It needs to be smooth and rounded. Okay, so let's look at this example here. So here we are, we've got a quadratic function. It's not quite in standard form, so just to make things a little bit easier, let's put it back into standard form. So x squared, we can think of that as like a 1x squared, and then minus 4x plus 2. Okay, so this is like our ax squared plus bx plus c. So a is 1, b is -4, and c is 2. So we're going to follow that step-by-step process. I've got them just written right out here so you can follow it. So find the axis of symmetry, the vertex, the y-intercepts, use this information plus that reflection I was talking about, and then we're going to graph the function. Okay, so axis of symmetry, I'm going to abbreviate here. Our formula is x equals -b over 2a. So we're just going to plug in these values. So -b, b already is negative, so it's like a -4, so it ends up positive over 2 times a. So this is 4 over 2, so that's 2. So our axis of symmetry is 2. So I'm actually just going to start plotting down here. So you go over to 2, 1, 2, and you plot that axis of symmetry. So that's going to be the first thing that you're going to want to lie down is that axis of symmetry. Then to find your vertex, what you're going to do is plug that 2 in, because the vertex is going to be somewhere on this line. We know that for sure. So we know that the x value is 2. We need to figure out what the y value is going to be. So for the vertex, you're going to plug in 2. So we want to find f of 2, which means plugging 2 into this function. Okay, so simplify this down. So I have 2 minus 4 times 2 plus 2 squared. Okay, so 2 minus 8 is -6, plus 4 is -2. So that means it's an ordered pair. So the vertex is 2 for x, which we found up here, and then -2 for y. So that's an ordered pair, and we can plot that. So right there would be our vertex. All right, and then last thing you were asked to find is the y-intercepts. Our y-intercept is super easy. It's always just the constant term. So if I plugged in 0 for x, these 2 terms would be gone, and the only thing that would be left is the 2. So if I plug in 0 for x, I get 2 for y, and that's my y-intercepts, which we can plot right there. That's the point 0, 2. Okay, so now last, use this information plus a mirror image. The last thing we're going to plot is that mirror image. So if you look over here, this is 2 units apart. So from the y-intercept to the axis is 2 units apart. So you're going to go another 2 units in the other direction so that you can plot a mirror image point. And the very last step is to connect them using a smooth curve. Okay, so that's your graph.